Welcome to Flashback Friday, Graphing Linear Inequalities, Algebra Teaks 3D. Graph the solution set of linear inequalities in two variables on the coordinate plane. Quick reminder how to graph a line. We're going to make sure your equation is in y equals mx plus b format, like this one, y equals 2x plus 3. If it isn't in y equals mx plus b format, rearrange the variables and the numbers until it is. In our example here, we have 2x plus 3y equals 6. First thing I will do is subtract 2x from both sides. That leaves me with 3y equals negative 2x plus 6. I will divide everything by 3 now, leaving me with y equals negative 2/3 x plus 2. To graph, we will start with the b. That is your base, where your graph touches the y-axis. Your m is how the graph moves from that base. It is always a fraction. If you are seeing a whole number, like m equals 5, turn it into the fraction 5/1. That m fraction represents rise over run, how far you go up or down, over how far you go left or right. For our first example, we had y equals negative 2/3 x plus 2. Our base is 2. That's our y-intercept. See, the dot appeared at y equals 2 right there. Our movement is negative 2/3. That is our slope. From the 2, we will go down 2, and then we will go to the right 3. That will be where we put our next point. Now we draw the line between the points, but which line? Equations versus inequalities. We were graphing y is equal to negative 2/3 x plus 2. So far, we graphed the y-intercept and one other point on our graph. Because this is an equation, we will use a solid line and we will not shade. Let's change it up a bit. What if it was y is less than or equal to negative 2/3 x plus 2? What does my line look like now? For less than and greater than, we will use a dashed line when graphing. For less than or equal to, greater than or equal to, we will use a solid line. I tell my students, if it's underlined, it's a solid line. If it's underlined, it's a solid line. If it's underlined, it's a solid line. So y is less than or equal to negative 2/3 x plus 2. The graphs of linear inequalities get shaded. For our graph, we want everything less than our line to be shaded. Here's our line. It was less than or equal to, so it got a solid line. And now I have shaded everything less than this line. What if, changing it again, we have y is less than negative 2/3 x plus 2. This example is just less than. It is not less than or equal to. Therefore, it gets a dashed line, and again, everything less than the line is shaded. We had a less than, not a less than or equal to, so it was a dashed line for this inequality. And again, we shaded everything less than the line. Let's do two more what ifs. What if we have y is greater than negative 2/3 x plus 2? What if we had y is greater than or equal to negative 2/3 x plus 2? For just our greater than, not our equal to, just our greater than, we have a dashed line, and I've shaded everything above that line. For our greater than or equal to, I have a solid line, and everything greater than that line is shaded. Now, what if there is more than one linear inequality on the same graph? This is called a system of linear inequalities, and the solution is only where the two graphs overlap. Let's add a second inequality to our first one. Let's add in y is greater than 5x minus 2. Our base is at -2. From -2, we move our slope, which is 5 over 1. So up 5 and over 1. We want a dashed line because it is just a greater than sign. It is not a greater than or equal to sign. And we are going to shade everything greater than the line. Here is y is greater than 5x minus 2 shaded on our coordinate plane. Here is our system of inequalities. We have y is greater than 5x minus 2, that is our dashed blue line, and we have y is less than or equal to -2/3 x plus 2, that is our solid purple line. Let's put both of these together on a graph, and we have our shaded solution where they overlap each other. Remember, their solution is just where the two inequalities overlap. So that solid black area, that is my solution to this system of inequalities. Let's check a couple of points and see if they are part of the solution. How about 0, 0? Is 0, 0 in the solution set of the system of inequalities? There it is in the yellow star. And yes, it is in our solution set. How about 3, -3? 3, -3 appeared right there as your yellow star. No, that is not in our solution set. That is not in the dark shaded black region where our two inequalities overlapped. How about -2, 5? That appeared right there, your gold star. No, again, that is not in our solution. Our solution is just the area that is solid black shaded. So what does this look like on the STAR test? I pulled the 2017-2016 tests and found a couple of examples for us to practice. Which graph best represents the solution set of y is less than or equal to -4x? Looking at this, let's eliminate two of these possible answers right now. This inequality says less than or equal to. See the underline? It should have a solid line then on the graph. So there is no way the answer is A or B. They use dashed lines. D is a horizontal line, a flat line, a line with zero slope to it, a line that is y is greater than or equal to -4. Therefore, our answer has to be C. For question 37, it said, which ordered pair is in the solution set of y is greater than or equal to 1/3 x plus 4? Well, graphing this, it has a base of 4. And from 4, it moves up 1 and over 3. It is greater than or equal to. If it's underlined, it's a solid line, remember? So I use a solid line to graph it, and we are shading everything greater than it. The graph looks like this. Base of 4, from 4, it moved up 1 and over 3. It was greater than or equal to, so it was graphed with a solid line. And because it was greater than, I shaded everything above that line. Now let's look at the points. Here are A, B, C, and D graphed for you. Which ordered pair is in the solution set of y is greater than or equal to 1/3 x plus 4? It's B. Our third example is going to be our most complicated, but we can handle it. The graph of 0.5x minus 2y equals 3 is shown on the grid. Which ordered pair is in the solution set of 0.5x minus 2y is greater than or equal to 3? So now they want us to change that line into an inequality. Fine, let's do that. 0.5x minus 2y is greater than or equal to 3. I'm going to solve for y. First thing I'm going to do is subtract 0.5x from both sides. That leaves me with negative 2y is greater than negative 0.5x plus 3. I will divide everything by a negative 2 now. Alert, 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 you have divided by a negative. Remember, if you are multiplying or dividing by a negative while solving an inequality, the sign flips. That may be new information, that may be a review for you, but you've got to remember, if you ever multiply or divide by a negative while solving an inequality, the sign flips from greater than to less than, or less than to greater than, either one. So that leaves me with y is less than or equal to 1/4 x minus 3/2. If you're wondering about the positive 1/4 x, I had negative 0.5x divided by negative 2. A negative divided by a negative was a positive. And 0.5 divided by 2, that's the same fraction reduced as 1/4. And then, of course, 3 divided by 2, 3/2. I will shade everything less than this line now that I have changed it from its standard format to y equals mx plus b format. I will be able to see which direction to shade. I should be shading everything less than the line, so the line looks like this. And here is point A, B, C, and D. Which ordered pair is in the solution set of 0.5x minus 2y is greater than or equal to 3? The answer is C. Good luck with your practice. I'm totally and completely proud of you. Have a wonderful day.